Math is a wonderful thing. Math is a really cool thing. So get off your act, let's do some math. Math, 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 math. 3 minus 4 is...
-1.
That's right. And 6 times a billion is...
6 billion?
Nailed it. And 54 is a 45 more than what is the answer, Marta?
9.
No, it's 8.
No, it's 9.
Yes, I was testing you. It's 9. And that's a magic number.
Good morning on Thursday, May 14th. We are going to do another subtraction bit of problems. We're going to make them a little more difficult. And in the reasoning in that, we're going to add some exponents here. We're going to go up to the power of 4. And remember, we're adding together like terms. Okay, so they have to have the same base and the same exponent in order for us to combine them together. But I'm going to first start at this problem here at the top. We all know that answer is 2, okay? But when we first did subtraction, 5 minus 3, in this class, we said we were going to change our subtraction to addition. And you remember what we said? What were we going to do? We were going to add what? We were going to add the opposite of 3. Okay, instead of subtracting 3, we're going to add the opposite. What's the opposite? Well, the opposite of 3 is a -3. So really, basically what I did is just distributed that negative subtraction into that and changed to addition. Okay, just like we're going to do down here, we're going to distribute. Okay, and that's what a lot of us didn't do in our last assignment. So we're going to distribute that negative, and then we're going to regroup, and then we're going to combine those terms that are alike. Okay, so I'm going to rewrite x to the 4th plus 14x squared minus 9. And instead of subtracting, we're going to add the opposite. What's the opposite of a -7? +7. Okay. What is the opposite of 3x? Well, that's a -3x. What's the opposite of a -6? It is a +6. Okay. So now we can, since we've distributed that negative, we can now combine like terms. So I'm going to regroup. We don't have any x to the 3rd power, so I'm going to leave a space there. We have an x squared. We don't have an x, so I'm going to leave a space, and we have a 9. Okay, and you'll see why I left the space here. I'm going to take these and bring them down below and put them underneath the like terms. Okay, so 7x squared, 14x squared, these are like terms, so I'm going to set them on top of one another. Okay, plus a -3x. There is no 3x's. There is no x variable in this polynomial. And then we have plus 6. Okay? So now we can combine like terms. There is no x to the 4th in the second polynomial. So we have x to the 4th, 14x squared and 7x squared. Same base, same exponent. We can combine those together. 21x squareds. Okay? Minus 3x, because there is not another x in the other top polynomial, and -9 plus 6 is a -3. Okay, so I'm going to bring back another problem that we're going to do here in a second that's not as easy, but remember, we distribute first. Okay, that's what I did here, and then we combine the terms that are alike. We figure out how to put them together so we can regroup them. And we combine the terms that are alike. These two are alike. These two are alike. This one didn't have anything in the other polynomial that was alike, and this one did not either. Okay? So we didn't combine those with anything. They just stayed the same. Okay, here's our second polynomial. subtraction problem that I'm going to give you. And you notice right off the bat that they're not in standard form. I like having them in standard form because then that shows me where the like terms are at. I can look and determine where they're at. So what I'm going to do is before I do anything, I'm going to change these so they're in standard form. Standard form means that we're going to write the exponents in descending order. So I'm going to go to my largest one, largest exponent, which is the second power. Okay. And then I'm going to go to my next largest, which is r to the first power. And then my last one, which was subtract 11. Okay. Now I'm going to go over to this one. Which one is my largest one here? R to the third power. Okay. Do I have an r to the second power? No, I don't. I don't have one in this one. But so then I just go to the next largest, which is 7r to the first. Okay. We don't see it there, but that's really what it is. And that is plus 3. Okay. So now I can distribute my negative. Everything's in standard form. Okay. Being in standard form, I don't miss any when I'm combining like terms. So I'm just going to rewrite this one down below. 2r squared minus 8r minus 11. We're going to change this to addition, and we're going to add the opposite of all what's inside this polynomial. So that's a negative r cubed. Subtracting the opposite of subtracting 7r would be adding 7r. And then this one would be plus a negative 3. Okay, we're going to add the opposite of that. The opposite of 3 is a negative 3. Now on both of these, you could just put these as subtraction, same thing. But we're going to leave them like that right now. So I'm going to take this side now, and I'm going to move it and put it underneath the other side. Okay, and now this is the largest term in this side, so I'm going to put it all the way over here because I don't have another r cubed, okay, in the top. I do have a 7r and a negative 8r, so I can put plus 7r underneath the minus 8r, and I have a negative 3. Okay, so now I've taken this one. It doesn't have a match over here. Okay, it doesn't have a same base, same exponent. These two do. These two are like terms, same base, same exponent. And these are both constants, so they are like terms. So we're going to combine all like terms now, and we're going to get a minus r to the third power plus 2r to the second. Now, negative 8r plus 7r. These 7 cancel out with 7 of these negative 8s, so we're left with 1r. Negative 11 minus 3 is a negative 14. Okay, there you go. Your assignment is a PDF just like yesterday, and there's only 6 problems, so you should be able to get those done, and then we'll come back and we'll work on multiplication of polynomials next week. Okay, see you guys. Have a great day.